My name is John Weymouth, and thank you for participating in the Pump Styles and Fluidics Terminology program. The objectives of this particular course explain the different types of phaco pump styles, describe fluidics terminology, and apply this terminology to different pump styles. Peristaltic pump. Definition is tubing stretched across a series of rollers. A rotating pump head engages the tubing. The tubing is pinched against the roller and the housing. Small amounts of fluid are trapped between the rollers in the tube, and a pressure differential is created, which creates a vacuum, and the fluid is drawn in the direction of the flow, of the rotation. This is a diagram of the peristaltic pump, where you can see their rotation of the pump pulls the fluid. The Venturi pump is driven by compressed nitrogen or compressed air. The gas is directed through a variable opening A into a chamber B, and then it passes over an opening C, as you'll see in the next diagram. The gas expands through B over the C area, and it creates a pressure differential. This creates a vacuum in the chamber that pulls the fluid into the aspiration line. So this is what the mechanism looks like. There is no moving parts. So on the right-hand side is where the high-pressure air is injected, and it flows all the way straight through to the exhaust. But as it flows through, it goes through a little different sized chambers, and it causes the gas to create a vacuum on port D, which pulls fluid or air or whatever they want into that flow. Fluidics terminology. Fluidics is the behavior of fluid, air, and particles in the interocular environment, and it's mainly influenced by the pump style. Irrigation, fluid that is being forced into the eye, usually a balanced salt solution, BSS. Interocular pressure, pressure that is maintained by the inward flow of irrigation solution. The greater the bottle height, the greater the pressure inside the eye. Interocular current, function of the location of the irrigation and aspiration ports. So when the surgeon has the needle in the eye and there's irrigation flowing into the eye, it sets up currents. Sometimes these currents aid in bringing particles to the end of the tip. Sometimes they keep the tip free of these particles. They typically want these particles to attract it to the tip. Aspiration. Aspiration is the removal of fluid from the eye. This is an example of irrigation and aspiration. The handpiece blue sleeve is where the irrigation is coming into the eye. That little hole on the end of the metal tip is where fluid is being sucked in. So by adding a little bit of pressure, they can grab onto a tissue, hold it, now increase the pressure, and then it pulls it into the port. They can go after little particles with that port, but if they turn it and pull it, and it pulls on the capsule, or they stuck on the capsule, they literally can rip the capsule, and that is something they try to avoid in surgery. The capsule they want to stay intact. All that other material that's in the eye is left over from the lens that was removed during the cataract surgery. This is typically the cleanup stage. Aspiration flow rate. This is the speed at which the fluid is removed from the eye. It affects the system response. AFR is the force that attracts material to the distal end of the handpiece. In layman's terms, the faster the pump spins, the higher the fluid flow. So they can control the fluid flow or the aspiration flow rate by the foot pedal. So if they press all the way down, they'll have the highest rate or somewhere in between so that they can control the fluidics currents inside the eye and attracting material they want to the tip. This is an example of a peristaltic pump where you have the rollers pinching the tubing and then pulling the fluid in the direction of the rotation. Another peristaltic action is when you swallow. When you make that motion and swallow, you're contracting your esophagus and it's forcing fluid or whatever you have in your esophagus down to your stomach by squeezing the muscles. Very similar to the pinching of the roller. Hence, when you swallow, that's called the peristaltic action. Another good example of the benefit of this is that if you're at a college party where you have a kegger and you're hanging upside down, When you drink the beer, it actually goes up to your stomach, all through the benefits of peristaltic action. Next, we have vacuum. This is the negative pressure created by a pressure differential. It's a suction force that is exerted on the fluid, air, or particles in the aspiration line. Followability. This is a term used by ophthalmologists. Followability, it's similar to attractability. It's the ability of the fluidic system to attract and hold materials to the end of the handpiece. It's really dependent upon the intraocular pressure and the aspiration flow rate, and it can be affected by the cavitation of the ultrasonic handpiece. So when the doctor is applying phaco energy to the needle and it's vibrating, that vibration will actually repulse particles from the tip. So they typically will grab a hold of a tip, hold it there with the vacuum, and then apply ultrasonic power to disrupt and suck and break up that lens material and bring it into the tip. Rise time. Rise time measures the speed at which a vacuum builds to the level that is requested by the foot pedal. In a Venturi system, if you have a very large chamber and you're pulling the air out of that chamber, and that chamber is connected to a little tubing going towards the eye, all that air has to be removed from that chamber before vacuum starts to show up at the distal end of the tubing. So what they can do is make that chamber smaller, and now the rise time is quickly. As soon as they touch the pedal, they have full vacuum pressure that they're looking for. With a large chamber, it takes a while. So in the older systems, the amount of time it took to get to the vacuum level you wanted was very slow at the beginning of the case. At the end of the case, it was very responsive. So in today's technology, they have basically created a smaller chamber that they keep the fluid level constant by using a peristaltic pump to pull the fluid out and using Venturi to create the vacuum. Compliance. This refers to how the volume in the fluid circuit changes in response to pressure differentials. In other terms, if your tubing is very, very flexible, it's compliant. A non-compliant is very stiff. So a non-compliant tube would be stainless steel. A very compliant tube would maybe made out of silicone. And that compliance is very important in cataract surgery because it can change how the eye reacts to breaks in the vacuum as particles are attracted to the tip and then get sucked in. And it causes what they term as chamber collapse. So we want to reduce that instability, so they use stiffer tubing. Occlusion. This is an obstruction of the aspiration port or tubing, and it usually occurs when either the nuclear material or the cortical material is being removed from the eye. So on the systems that are out there, when the tip gets occluded and the pump rotates to pull to the vacuum it wants, as soon as the pump stops because it reached its vacuum, everything stops in the system and the machine will give a bell indicating that the system is occluded. The doctors will use this feedback at lower vacuum pressures to know that they have enough force to pull or strip some material, and then they'll push the pedal all the way down, increase the vacuum, and the occlusion is pulled through. Venting. Venting is a process by which the negative pressure that's in the tubing is equalized to atmospheric pressure. And there's two methods of doing this. There's called air venting and fluid venting. Air venting, the pressure is equalized by opening the aspiration tubing directly to the air, to the atmospheric pressure. This is less desirable because the air that is introduced into the tubing can cause a negative effect. It basically, air will act like a spring. Instead of being nice and firm and things happening directly, there'll be a lag time. So they do not like air venting. That's old technology, but there are still some systems out there that are in use that use air venting. Fluid venting, the negative pressure is equalized by opening the aspiration line to an irrigation or a fluid line. So the vacuum is reduced, the fluid will not be able to expand or contract as easily as it is in air, and so it has little impact on the stability of the chamber. So it's the best way to do it. Surge. Surge occurs when the vacuum is built up due to an occlusion and the occlusion suddenly breaks free. The fluid in the high pressure anterior chamber tends to rush into the low pressure phaco tip, and if this inflow cannot keep up with the outflow, the chamber will fluctuate. This instability is one of the key areas the manufacturers are trying to solve. Some do it through physics, others do it through pressurizing the bottle or pressurizing the infusion pressure of the bag very fast. So there's a variety of ways of doing it. Some are safer than others. But surge is a problem when you have very high settings and you're trying to do surgery quickly. You can cause some instability inside the eye. So, peristaltic versus venturi. Irrigation of both systems is either gravity-fed or pressure-fed. Followability with the peristaltic pump increases as the aspiration flow rate does. Rise time and vacuum increase followability in a venturi system. And venturi is much more aggressive, although the peristaltic can be modified and change the AFR rate very high to kind of mimic a venturi system. All peristaltic pumps need an occlusion to build vacuum. In other words, something needs to be on the tip for the vacuum to rise. All peristaltic pumps have a separate aspiration flow rate and vacuum settings. Venturi only has vacuum. And the rise time is adjustable on a venturi system pumps, and in peristaltic it's preset, or you can make it controlled by the foot pedal. Quick review of the peristaltic pumps. Name and explain the two fundamental pump styles of the phaco machine. What is followability? What type of pump will have aspiration flow rate as a machine setting? What type of pump results in instant vacuum? And briefly explain rise time. Thank you.